Hello, hello. Yeah. I'm Anurag, co-founder of Avail. Today, I'm going to give a talk on horizontal scaling via fast cross-chain interoperability. So before starting, let me give you some context. What is Avail? Avail builds rollup-centric infra. We started off with building this state-of-the-art data availability layer. We are adding a light execution runtime on top of Avail to enable things like rollup interoperability and so on. And so today I'm going to discuss a little bit about this concept in which blockchain architecture has been progressing. If you kind of look at how blockchains really started, like they started off very monolithic architectures like Bitcoin, Ethereum, and so on. And so in general, initially there were these very L1 sort of constructions, but until a few years ago when rollups came into the space, there's been now hundreds of chains that are being launched because it's very easy to now spin up chains. And so the status quo is now that these are very fragmented ecosystems, right? So if you see, there's just lot of L2s, lot of L3s, for example, and it's good, really, right? Essentially, it's in the sense that it's no longer very hard to spin up a chain like it used to be with spinning up a validator set and so on. And so the block space scalability problem has been kind of solved to a certain extent because there's no dearth of cheap block space. There's just too much scalable block space at the moment, and but the issue is that we've gotten into this very fragmented landscape. Lots of L2s, lots of L3s, lots of bridges, and so it's been very confusing for users to kind of navigate this landscape. Typical cross-chain experiences are, you have to lock your funds on one chain, basically mint on another, and then burn, unlock, it's every time, I have to do a transaction. If I have some funds on Base, I need to do some transaction on Solana. So, it's a pain, right? And this is nowhere near Web2 UX, for example. And so really what the question that we posed ourselves is, can we kind of get to this scenario, right? If you were to be able to interact with any app on, most chains from any other chain, how would that look like, right? Essentially, today if you see so many chains, right? Funds across so many different chains, how do you kind of solve that? And shouldn't require trusted middlemen, and maybe can we eliminate the notion of bridging? Bridging is always going to be there, but can we kind of remove UX from the bridging? Do users have to explicitly bridge, for example? And that's when we kind of started working on this problem, and we realized that because a lot of this is going to be very ZK rollup driven, for example, can we just solve this using a combination of proof aggregation using ZK. The first iteration we are doing using TEE, but in general, this is what we have been really working on. The upgrade to the Avail DA layer is the Nexus upgrade, which is basically a chain precursor to chain abstraction, really, and it really brings the interactions from an n cross n sort of a chain interaction into this thing called the Nexus middleware, which kind of handles all the complexity of the cross-chain interop for you. This literally, essentially from a UX perspective, what we are trying to get at is, even if your asset is on, let's say, Base, Arbitrum, Solana, can I do a transaction on Ethereum, for example, or on one of the newer L1s, for example, in one click? Because that is when we will be able to kind of reach simple user-friendly sort of use case. Otherwise, it's just where do I bridge to? Should I switch the network? What network am I on, for example? Are my funds stuck somewhere, for example? And so that is really what we want to solve. And so we started off with the ZK approach. That's a more, like a final guarantee kind of approach. But something that we are releasing in Q3 this quarter is the T interop, which makes it easy to do cross-chain apps. So if I have funds on Base, I can do transactions on Lens, for example. And these are the kind of latencies that we are looking at. For most chains should be in the order of, like 5 seconds. For the OP approach, for the T, 10 seconds is the upper bound. I think anything between 1 to 4 seconds is what we are aiming for example. In general, I don't want to get into all the technical complexities here. In general, I will kind of put this on my Twitter tweet so that you can go through the technical slides. But this is, in general, what are the concepts that we are using in general. Why we are uniquely positioned to do this is because that's why really we build Avail. Initially, we started with the data availability infrastructure. Like contrary to public perception, like data availability is not data storage. It's used to, tracks, ordering for chains. And so that's why, we need to verify these two components, the data availability and the execution. So essentially, if we are able to build light clients for both these approaches, you kind of solve that problem in general. And so with this, you have trust minimized guarantees and long tail asset stuff. Again, skimming through some of this, for example, not to get in too much into the weeds, but essentially everything around execution, light client verifiers and data availability light client verifiers. In general, like the main thing that we want to really arrive at is, irrespective of all the proving systems, all the different implementations out there, what we essentially do is we try to standardize the inputs to kind of the proof aggregation circuit, so that essentially we can then standardize communication between these rollups to have more uniform proofs and verifiers. This is technically the overall architecture. We have like each chain, we have a Nexus adapter that kind of standardizes the inputs to the Nexus. All of them goes into a verifier. We verify the entire chain state using both a DA light client verifier and an execution proof verifier. And so that is how we are able to kind of give these guarantees. For faster latency guarantees, we are initially starting off with TE or Trusted Execution Environment verifiers. And eventually, we will transition everything to a ZK, like verification mechanism. What becomes possible is also contingent execution. What that really means is that I can do asynchronous cross-chain communications in the sense that if I buy an NFT on one chain, that only goes through if I make a payment on the other chain, for example, and so on. So more akin to more Web3-like experiences. So for example, if you kind of think of how Web2 really works is, like you buy a product on Amazon or, like let's say Alibaba, for example, you kind of put in a request to buy the product, then you put in another request for the payment, and only when the payment goes through is the product then delivered or processed, for example. And this is what happens in Web2, and that's why you get these very seamless experiences via asynchronous UX. And what we really want to do is bring that experience to Web3 in the sense that can we do more of these asynchronous experiences which can be more parallelizable. Yeah, so I just keep it short. Like in general, that's the upgrade that's coming. It's coming pretty soon. And very happy to be giving this speech today. Yeah, thank you.